Hello everyone. Welcome to my presentation on SQL injection. I'm Robert Pistona. Let's go ahead and get started. So what is SQL injection? Well, it's an attack, basically. This is a technique that allows an end user to run unintended SQL code on our database. So think of a web application that has a form, maybe for a user sign in or register, and an attacker will use these input fields as a way to actually insert their own SQL statements and have it run on our database. SQL injection is very old and it's very common. It's one of the oldest vulnerabilities and it's still very, very common to see today. It's also very dangerous. Anything from being able to see data that a user shouldn't be able to see all the way to a system takeover is possible with SQL injection. And SQL injection is also largely avoidable. With proper coding practices and handling user input correctly, we can avoid a lot of the risk that comes with SQL injection. So to kind of quantify on what we just touched on as far as being old and common, SQL injection was first discovered in 1998, so it's going on about 23 years old now, and it's currently number one on the OWASP top 10 list of web application security risks. It got inside the top 10 on this list in 2007. It took the number one spot in 2013, and that's where it is today. A company called EdgeScan, who offers computer security services worldwide, they publish a report every year, and in their 2020 report, they found that SQL injection was the cause of 42% of the critical vulnerabilities for internet-facing web applications. So we can see that this is still very common to this day. So what are some of the effects of SQL injection? What can happen if an attack is successful? Well, any number of things really. It kind of depends on the attacker's skill and imagination. SQL injection allows an attacker to spoof identities. So depending on who they are pretending to be, they may have some pretty elevated privileges on our database. One or more CRUD operations might be possible to run on the data that's in our database, and if we have sensitive data there, that would be vulnerable. Downloading files from the DBMS file system is possible. Other administrative operations, such as shutting down the DBMS, is also possible. And this last bullet point here, issuing commands to the host operating system, we'll take a look at an example of how that can be done with SQL injection as well. So what is the cause of this vulnerability? Well, really any application that connects to a database and accepts user input should be considered vulnerable to SQL injection attacks. Specifically, if they're written using dynamic SQL statements. A dynamic SQL statement is one that is generated and ran at runtime. So a user fills out the form and clicks submit. When they click submit, we take their input, we make a SQL statement, and we run that statement on our database. I've got a basic example listed here in the slides. I've also prepared this example in SSMS, so let's go ahead and take a look here. Let's pretend that we have a business called Patty's Pub, a little bar in Philadelphia you might have heard of, and they have 5 employees, and they have a website where the employees can sign in. They provide a username and a password. So here, what I'm doing is I'm taking that username and that user password. We've got F Reynolds, password is toe knife exclamation, a little interesting. And then here is the statement that we are generating dynamically with that user input. And if I run this, we get what we would expect. Okay, you are Frank Reynolds. Here you go. Here's your information. We've got the query right here that was generated, and it looks very normal. If an attacker was going to try to use SQL injection, one thing they might do is close this password string right here early and then attempt to insert their own code. So this would be the injected code right here. And I'll run this, and you see there's only 5 employees, so we get everything from that table. D, Charlie, Mac, Dennis, they're all they're all here on display. And we look at the query that was generated with SQL injection. I'll just paste it in here. We get the normal statement, F Reynolds, toe knife, exclamation, but then the attacker has closed that password string early and then added or 1 equals 1 to the where clause of this statement. And then they've commented out our single quote character. So this will return true for every record in the table and just give them everything. So go back here, you can see all 5. And if you're a fan of the show, you might imagine everyone sitting around the bar with a computer, and then somebody says, wait a second, guys, I think we've been hacked. Okay, that's enough of that. If you're not a fan of the show, I apologize. So that was a somewhat basic example, but once we know the vulnerability is there, we can really kind of take it and run. A lot of database servers allow for multiple statements to be run if they're separated by a semicolon. So here I've altered our example from the previous slide to include a semicolon and then just go ahead and drop the table DBO users. Now this would require that the attacker has the privileges to drop this table and that they know the name of the table. But in reality, table names can usually be guessed, or they might inject some code that runs with an error to try and view those error messages. Sometimes table names can be present in an error message. This last example here, XP shell, XP command shell, is what I mentioned earlier, when an attacker could actually run commands on the operating system itself. And I've got a little walkthrough of this as well. So on SQL Server, this is something that needs to be enabled. So I'm just going to go ahead and enable that, and then I will run this here. And all this does is print the directory of my C drive. I mean, this is my personal computer C drive right here, and I ran that out of SSMS. You can insert any kind of commands that you can think of here, PowerShell scripts or really anything. So your skill and imagination is kind of the limit there. So how do we prevent SQL injection from happening? I have a list here. The first 4 are kind of ordered from best to worst. And so the first would be prepared statements. This is our strongest defense against SQL injection. And what this is, you might hear it called parameterized queries or statements with variable binding. This is a way for a developer to define the statement that we want to run before any user input is included. So it's not dynamic SQL. It's not at runtime we're going to create this statement and then run it. It's already prepared. To kind of illustrate this, I have another example. Still using our dynamic SQL example from earlier, but this time I've rewritten it to be parameterized. I'm using variable binding. So first thing is I've changed the user inputs to have a W, so I know that these are from the web. These are from the web user. And then here I've got my statement defined. So the database knows this is the statement I'm expecting you to run. Do not run anything else. And I've included the username and password as variables. Down here, I define what those variables are. They are both going to be in varchars with a length of 50. Not coincidentally, that matches our input from the web user. And then the very last line of code here, SP execute SQL, I'm going to pass the SQL statement that I want you to run. Here's a definition of the parameters that are inside of that statement. And then here is the variable binding. Username is going to come from the username web, and password is going to come from the password web. So I can run this in a normal situation, a non-SQL injection version, and we get Frank Reynolds just like we would expect. And if I run the malicious version where they attempt to escape the string early and append to the where clause here, we're going to get nothing back. Okay, you cannot escape the string early. It's going to treat this entire input as a string. So that is our strongest defense against SQL injection. Stored procedures are next in line. They parameterize queries for us. They are hosted on the database side rather than a prepared statement might be inside of your web app code, your JavaScript or your .NET or whatever. So stored procedures are defined beforehand. They run on the database, and they aren't as good as prepared statements because you can run dynamic SQL inside of a stored procedure. It kind of depends on how you've written it as a developer. So best practices apply. Don't include dynamic SQL in your stored procedure. That defeats the purpose. They also require enhanced permissions compared to prepared statements. Like if you're using prepared statements, all you really need is the web application database user really only needs DB data reader and DB data writer permissions. With stored procedures, you have to have execute permissions because, again, this is stored on the database. So you have to be able to execute that code. And unfortunately, a lot of times people end up giving the database user for the web application DB owner rights. So they have way more privileges than a prepared statement. Next on the list is allow list input validation. This would be a way to kind of check user input and validate that it is something that we're expecting. Some things cannot be included in prepared statements. If you want your user to select a table, as an example, you cannot put a table as a variable in a prepared statement. Just the way that SQL code is written, it won't work. So an alternative is to just give them a list of tables, maybe a drop down or something where they don't have to type it themselves. Or sort order is another thing. You cannot put ascending or descending in a variable and have it run in the order by clause. So maybe again, just in your JavaScript code or your .NET code, just make that a Boolean, 1 for ascending, 0 for descending, and then inside your code on the web app, convert that to ascending or descending based on the value of that Boolean, so they're not typing that in themselves. And then the last thing here, escaping user input, this is really a last-ditch effort. This isn't too great. If you think about when we were trying to sign in as Frank Reynolds and we closed that string early and appended some code, we would want to escape that single quote character as an example, so that the input is treated as an entire string versus a little bit of a string and then some appended code. But this is not a great practice because you're really just shooting in the dark. You're trying to guess at what somebody's gonna type in and how to handle it. And again, the skill and imagination of all these attackers is going to win here eventually. So this is, again, the bottom of the barrel. And I've also included enforcing least privilege, not at the bottom of the list. This is just a side note that we should always be doing that. So if we are attacked and it is successful, hopefully they'll have a limited scope of privileges. So as a review, some key takeaways here. SQL injection is an old, dangerous attack technique that is still extremely common today. This is when attackers misuse our input fields to attempt to insert their own code and have it run on our database. Proper coding practices such as parameterized queries offer a strong defense against this attack. And always practice the principle of least privilege with your database users and with the server itself. So no XP command shell, please. Thank you very much. I will leave you here with this little comic I found on the internet. You can read it yourself. Yeah, thank you.